In this video, I'm going to be introducing you guys to logical operations. And the logical operations I'm going to be specifically talking about is AND, OR, NOT, and XOR, also known as exclusive OR. So I'll talk about all of these guys, but first let me show you the symbols for the AND and OR logical operations. So the symbol for AND operation is just a caret that's kind of facing down, or V, upside down V. But the logical operation for OR is just a caret that's facing up, or just a V, just a regular V, okay? Now, if you type down V on your keyboard, it's not actually going to look like what you want it to look like for these logical operations. But with these logical operations, you have a P and a Q on both sides. So P and Q are just arbitrary values. These are just variables that could be anything. We could have had A and B here if we wanted to. But most of the time in this discrete math course, you're going to see P and Q. And these P and Q values can have true or false values. Q can have true or false, right? Those are the only two options for our logical operators. And right here, we have a truth table. Okay? And these truth tables can actually help us understand what's going on in the AND operation and the OR operation. So let's go ahead and write down P here, and the operations. So this right here, remember, is OR, just the V, and this right here is an AND, upside down V. Okay? And I'll show you what they each do. But first, let me go ahead and show you all the possible combinations of what P and Q can be. So notice how I wrote down all the possible combinations, true and true, right? So remember, P and Q can only have the option true or false. So either P and Q are both true, or P is true, Q is false, or P is false, Q is true, or both are false. And these are the only options. And you can write down all the options, these 4 options, right over here. So with this operation, let's go ahead and take a look at the first possible scenario, when both P and Q are true. When they're both true for the AND operation, you get true. So, and you can kind of think of it as this. If P and Q are true, then the result is true, right? But if P and Q aren't true, if both of these guys aren't true, then AND gives you false. And in this case, both of these guys aren't true, right? P and Q both aren't true, therefore you get false. Both of these guys, P and Q, aren't true, right? There's a false here. Therefore, you get false for the operation. And for false and false, both of these guys end up being false. Therefore, they're not both true. So the AND operation gives you false. Now, how about the OR operation? Well, for the OR operation, either P or Q, if either P or Q are equal to true, then the OR operation gives you back true. So just one of them, just one of them, P or Q, can be true, and the resultant OR operation gives you back a true. So in this case, we have true and true. More than one of them are true, so that's even better. We get true for the OR operation, right? So P or Q gives you back true. Now right here, P is true, but Q is false. Here's the thing. This is an OR operation, not the AND operation. So just one of them is true, right? P is true. Therefore, the OR operation gives you back a true. In this case, Q is the one that's true. P is false. Therefore, the OR operation gives you back a true. Now, the only case when the OR operation gives you back a false is when both P and Q are false. So you get a false here. Now, let's do a quick little test to show you what these AND and OR operations actually do. Now, don't think of it as a test because it's not stressful, because you're watching a YouTube video. But let's go ahead and do false. What's the symbol? Remember what I said before. But false, whatever the symbol is, with true. What will this give us back? Well, this right here is an OR. It's an OR operation. So false ORed with true is true. Remember, for the OR operation, just one of them has to be. Just one of them, either P or Q, has to be true in order for you to return back a true. Okay, how about this? How about false? How about, actually, let's do true and true. Okay? What will this logical operation give back us? Well, this entire guy will actually simplify back into a true. Remember, the upside down V, or downward facing caret, is the AND operation. And for the AND operation, the only time when the AND operation gives you back a true is when both P and Q, or both the inputs, are true. Right? So the logic we get outside of this AND operation is true. So you can kind of think of these operations as something that just simplifies the entire problem. It combines this true and true together, right? Just like the previous one. Let's actually undo. It combined this right here, this OR operation, just combined false OR with true, right? False OR true, and just combined it and simplified it into a true. Now, how about these quick little symbols here? What is this and what is this? Well, this right here is the NOT operation, and this right here is the exclusive OR operation. Let's go ahead and draw the truth tables for this. And in the case of the NOT operation, we only have one variable. We only have P, right? So if we only have P, then we only have true or false. Those are the only possible combinations of inputs that you can put into the NOT operation. How about the exclusive OR XOR, if you want to be fancy, operation? Well, it's simply just an addition symbol with a circle around it, okay? And it has two inputs, therefore the possible combinations of P and Q look like so. Right? So how about, let's cover the NOT operation first. All right? This is the most simple one. This is the most simple one because what does it do? All it does is just flip your value. Right? So if you apply the NOT operation onto P when is equal to true, then the output is simply just false. If you apply the NOT operation onto P when P is false, then it turns to true. So if you see NOT T, what does this stand for? This just simply stands for false. Right. And if you see NOT false, this simplifies into true. It just flips true to false and false to true. NOT operation, very simple. What about exclusive OR? What about exclusive OR? Well, here's the thing about exclusive OR. The only time exclusive OR gives you back a true is when only one of the inputs are true. Both can't be true, you will get false. So this right here is what the truth table looks like. In this case, let's go ahead and take a look. Let's use a better color. But in these cases, when only P or only Q is true, that's the only time when exclusive OR gives you back a true. In the case of both P and Q being true, you get a false because it's not exclusively OR, right? So exclusive OR only gives you back true. The operation only gives you back true if only one, either one of P or Q are true.